Hello, welcome back once again. Today we have a very nice radical equation. And according to the author of this problem, 95% of students fail this problem. So how are we going to solve this problem? For a quick solution, we know that x must be a perfect square. So let us list the number of perfect squares starting from 1 to 64. We have 1, right? We have 4, right? We have 9, right? We have 16, we have 25, we have 36, and we have 64. Sorry, I forgot we have 49 right over here, right? Okay, cool. Now let us start checking out the one that will satisfy this equation. We know that x must be a perfect square, right? So if we plug in 1, we need x plus 28 to also be a perfect square, right? So if you plug in 1, that will give us 29, and 29 is not a perfect square. If you substitute x, if you substitute 4 for x, you get 4 plus 28, which is 32. That is not a perfect square. When you use 9, you get 37, which is not a perfect square. You use 16, you get 44, which is not a perfect square. You use 25, you get 53, which is not a perfect square. You use 36, then you have 64, which is also a perfect square, right? Okay, with this idea now, we can actually write this. We have square root of x plus 28 plus square root of x is equal to 14. Now we know that for x equals 36, this one here is 64, right? So this one here is 64, that is square root of 64, plus for x equals 36, right? So we have square root of 36. So let us check out. So this is 8 plus this is 6, and obviously this is equal to 14. So therefore x is equal to 36 is our solution. Okay, but let us solve this problem algebraically. So remember, we have square root of x plus 28 plus square root of x, that this is equal to 14. Let us go ahead and square both sides. So let's square both sides of this equation. From this left hand side, let us apply this property. A plus b whole squared is equal to a squared plus b squared plus 2 times a times b, right? So with this property, the left hand side will have this first one squared. Remember that the square root will cancel the square, right? So that will give us x plus 28 plus this one here squared. Square will cancel the square root, leaving us with x plus. So we're going to have 2 times square root of x plus 28 multiplied by square root of x. So this is equal to 14 squared is 196. From here, we have 2 radicals, right? So we can actually write that as square root of x times x plus 28, right? But here we have x plus x, which is 2x, plus here we have what? We have 28, plus 2 square root of x times x plus 28 is same as x squared plus 28x. So this is equal to 196. If we divide throughout by 2, we get 2x divided by 2 will give us x, plus 28 divided by 2 will give us 14, plus this expression here divided by 2, we have just the square root of x squared plus 28x. So this is equal to 196 divided by 2 will give us 98. You get the idea? So now these 2 terms here, let us move it to the right hand side, and that will become negative. So now we have square root of x squared plus 28x is equal to 98 minus 14 from here, right? So 98 minus 14 will give us 74. Is that 74? Oh, sorry, 84, right? So that will give us 84, then minus x. So square both sides again because of the radical at the left hand side. Now we can see we can cancel these 2. Then we'll have here x squared plus 28x is equal to, expand this. If you expand this, you're going to have x squared plus 7056 minus 168x. So because x squared is positive from both sides, so they will both cancel, right? Then we have here 28x plus 168x. That will give us 196x. This is equal to 7056. So divide both sides by the coefficient of x, which is 196. And from here we get x is equal to, this divided by 196 will give us 36. You can see 36 is the correct answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share.